All right, first period. Sorry we got cut short for technology reasons, but I want to go through 5 problems here, about 2 minutes per problem, to help you guys with some of the more difficult factoring problems and hopefully give you some tips and tricks to use on the quiz, okay? Whatever I don't go over, please do for homework. Come in with questions, and we're going to take about the first 15, 20 minutes of class answering questions. So the first one that I want to look at is number 9. Number 9, I notice that there's a GCF. For every single problem that you do, you need to ask yourself, do the 2 different terms share a common factor? These do. They share a 5. So I can pull this out, and I have 5 times x cubed minus 8. Okay? But I'm not done here, because this x cubed minus 8 is actually the difference between 2 cubes. So I need to use my formula here. And the formula tells me, this 5 can just chill out here. The formula tells me that I have a small parentheses and a big parentheses. And if you remember, we have a and b, we have a squared, we have ab, and we have b squared. Okay, and we'll deal with the positives and negatives at the end. So I'm going to take x to the 3rd power and do the cube root of that, which moves down to x. Then I do 8, and I cube root that down to 2. Now that I know a and b, I should be able to fill out the rest of the formula, because if a equals x, then what's a squared? Well, that's x times x. What's a times b? Well, that's x times 2, which is 2x. And what's b squared? That's 4. And as far as my positives and negatives go, we've got the same sign as the problem, the opposite sign as the problem, and always positive. This is our answer, completely factored. Can't go any farther with that one. First problem down. Problem number 10 is a very tricky one, okay? We talked about this in my 3rd period, so I want you guys to hear it as well. There are only 2 terms in this problem. Here's the first term, and here's the second term. Okay, the way you can tell if there's a term is when there's a plus or minus sign between it. So for example, number 12 has 1, 2, 3 terms. Okay, so number 10 only has 2 terms. So that means it's either going to be difference of squares, or it's going to be another cubes problem like we had in number 9. These are perfect squares. Ding, 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 that's the trick. Okay? So believe it or not, we're going to do this the same way that we would do x squared minus 9. And for x squared minus 9, we would write 2 parentheses. We would put the square root of the first term in the first spot and the square root of the second term in the second spot. So for this, it's just going to be a little complicated, but it's the same thing. We're going to do 2 parentheses, and I'm going to put the square root of this first term. So the square root of that, well, the square root of a quantity squared is just the quantity. And that goes in my first spot in each of my parentheses. Then I do the square root of the second term, and that is also just the quantity. But here's the piece where there's one extra step. We have to do 1 plus and 1 minus. And on that minus, we got to make sure that we distribute that negative to both the x and to the negative 2. So when we clean this up, because now we've factored it, we're done, but we can simplify it. What I mean is, in this left side, do you notice how we have x and x to make 2x? And we have 1 minus 2 to give negative 1. We can clean that up a bit. And then over here, notice what we have. We have x minus x. Those cancel. And then we have 1 minus a negative 2, which is 1 plus 2, which is 3. So this ends up being our final answer for number 10. It's a difference of squares problem, but it's a little more complicated. Okay? Next one. I want to do, let's do number 12. Okay? We've got cosines in here. Kind of a curveball. But this, with cosines, is the exact same as if it was just this. It's just our variable in this one is a cosine. So we're going to pretend like it was, honestly, you can even solve it like this and then just swap back in cosines for your x's. That might be helpful for some of you who are confused by seeing the trig there. So let's leave it like this. And there's 1, 2, 3 terms. So that means it's trial and error. So I'm going to use 2 sets of parentheses. 3x squared is going to be broken down into 3x and 1x. And then I have to figure out how to get 26 using 9. So I could use 1 and 9, or I could use 3 and 3. I think I'm going to use 1 and 9 because I know that 9 times 3 is 27, and that's awfully close. So if I put a 9 here, and I put my 1 here, 3 times 9 is 27, and I want that to be negative. And then I want this extra 1 to be positive. So I think that's going to work. Let me do a quick check. And the way you can check is you do the outside, 3 times 9, which is 27. And then you do the inside, which is, sorry, that's a negative 27, which is 1. And that equals negative 26. Yeah, so it works out with my middle term. So let me erase this. And let me just write my final answer with the cosines. We can't just ignore those. So it's 3 cosine plus 1 times cosine minus 9. And that is my final answer there. Okay? So when you're looking at number 11, you do it the same way. When you're looking at number 14, because I don't have time to do 14, this is just a grouping problem because there's 1, 2, 3, 4 terms. Okay, so pull out your GCF of the first 2, and then pull out your GCF of the second 2, and treat it like a grouping problem. Okay, I want to finish with, I think this is the last one I'll do, kind of a combo between 17 and 18. I will say, this is a difference of 2 squares. Notice perfect square minus another perfect square. And this is a cubes, so you can practice the formula again. But let's look at 17 and 18 because these have multiple steps. For 17, that looks complicated. That 56 in the front is scary. Can we pull out a GCF? No, we cannot. They don't all share something. So, wait, yeah, actually they do. They share 2 x's. They don't share a number, but they all have at least an x squared in common. So let's pull out the x squared. And let's go 56x squared plus 9x minus 2. Okay? All right. We can go farther because this has 3 terms. So I'm assuming this can break down. So let's save the 56 for last because that has quite a few factors. But I know that the negative 2 is just going to be 2 and 1, right? So how do we get 9? What are factors of 56? We've got 1 and 56. That's probably too big. We've got 2 and 28. That's probably too big. We've got 3, no, 4, and 14. Could be onto something there. And then I know 7 and 8. I bet these 2 are too big. So it's either 4 and 14 or 7 and 8. So let's try... let's try 4 and 14. And like, look, I don't know if this is going to be right. I'm showing you guys how we just try it, okay? 14x and 4x. So what does this make? This makes a 14 and this makes an 8. 14 and 8 can't work back to get us 9. So that's not going to be correct. What if I switch them? This is 4 and this is 14. That'd be 4 and 28. I don't think that's going to work. So I don't think that that works. So let's try 7 and 8. Let's try 7 here and 8 here. Okay. So what do we got? This is a 7x. And this is 16x. Okay, we're on to something because that subtracts to be 9. So this is going to work. I just need to make sure my signs are in the right spot. I need the 9 to be positive. So I need the biggest one, the 16, to be positive. And I need this one to be negative. So that works. And notice, you got to witness me doing trial and error there. And then I bring down my x squared. And so there's not a necessarily method just to get it right on your first try. You got to think of the factors and practice a few of your multiplications and see what you get. Okay, last one, gang, is this x to the 8th minus 1. This is a difference of 2 squares. Any variable that has an even number is a perfect square. Okay, so when I break this down, x to the 8th gets broken down into x to the 4th and x to the 4th. and 1 gets broken down to 1 and 1 with a plus and a minus. Here's the thing though, and this is the last minute of the video. Don't stop here, because now look what we have here. We have another difference of squares that can go farther. So this needs to go farther. This first one cannot, because it's 2 squares with a plus sign. But if it's 2 squares with a minus sign, then it can be broken down a little farther, right? And then what do you know? Once again, this can be broken down even farther to x plus 1, x minus 1. And that's as far as it can go. So let me bring stuff down. We've got this. I can bring this guy down, and I can bring this guy down. So my final answer has about 4 sections, and it is completely factored. Okay, thank you guys. Reminder, where your homework is it's making me log back in, but I want to make sure you see this so that there's no confusion, because we kind of had to hustle out of class. Pre-calculus assignments, and it's right here, factoring quiz review. We didn't get to the triangles, don't worry about it, just the factoring quiz review right here with answer key included. Come in with questions, guys, and I will answer all of them. All right? Good luck.